This is SpaceTime Series 28, Episode 18, for broadcast on the 10th of February 2025. Coming up on SpaceTime, NASA raises the threat level for a potentially Earth-impacting asteroid, plans for a new test to try and identify dark matter, and Martian lava rocks spreading light on a critical period in the red planet's history. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has dramatically raised the threat level posed by a recently discovered near-Earth asteroid. NASA's Jet Propulsion Laboratory in Pasadena, California, says the space rock 2024 YR4 now has a 1 in 43, that's a 2.3% chance of hitting the Earth on December the 22nd, 2032. Now, that's double last week's estimate of 1 in 83 or 1.2% chance of a direct hit. The figures are consistent with independent estimates by the Center for Near-Earth Object Studies and the Near-Earth Object Dynamics site. Meanwhile, the European Space Agency's Planetary Defence Office says it's now begun to closely track the newly discovered asteroid. 2024 YR4 was first detected back on December the 27th by ATLAS, the Asteroid Terrestrial Impact Last Alert System. Following its discovery, ESA elevated the asteroid to the top of its asteroid risk list, and astronomers worldwide have started undertaking high-priority follow-up observations, closely monitoring the space rock to try and find out more about its orbit and trajectory. It's currently ranked as a level 3 on the Torino Impact Hazard Scale. And that suggests a close encounter which would warrant careful attention by both astronomers and authorities, as well as the general public. Now, based on the amount of observations available so far, 2024 YR4 appears to be on an elongated elliptical orbit around the Sun. It's currently moving away from the Earth, and that's making it more difficult to track. So, ESA's coordinating observations using larger, more powerful telescopes, such as the Catalina Sky Survey and the European Southern Observatory's VLT, or Very Large Telescope, in Chile. The asteroid makes its next close approach to Earth on December the 17th, 2028. While a near miss of around 106,200 kilometres in 2032 is still likely, with a 98% chance, any potential Earth impact would be along an arc running from the Central Eastern Pacific Ocean across northern South America, then the Atlantic Ocean, then equatorial Africa, and finally onto northern India. The asteroid's between 60 and 90 metres across. An airburst explosion of an asteroid of this size would be the equivalent of about 8 megatons of TNT. Now, that's more than 500 times the power of the Hiroshima nuclear bomb. Now, if YR4 is a rubble pile asteroid, and most of them are, then it would likely airburst in the atmosphere, similar to the famous Tunguska event in 1908. That's when an asteroid or comet fragment measuring around 30 to 50 metres wide exploded in the skies over Siberia. That blast flattened over 80 million trees in a matchwood across an area of over 2,000 square kilometres, with a blinding flash bright enough to be seen a third of the way around the world in London, where it was reported that the explosion was so bright it allowed people to read their evening newspapers without the need to turn on lights. On the other hand, if YR4 is a rocky or iron asteroid, it'll cut through the Earth's atmosphere like a knife, slamming hard into the planet's surface, producing a massive crater as large as Sydney or Melbourne's central business district, with a destructive shock wave flattening buildings up to 20 kilometres away from ground zero. If it explodes over the ocean, the blast wave could trigger a tsunami. However, as more and more is discovered about this asteroid and its trajectory and orbit are better understood, it's expected and hoped that the risk factor will drop. Needless to say, no matter what happens, we'll keep you informed. This is SpaceTime. Still to come, a new test to try and determine what mysterious dark matter might be. And scientists say Martian lava rocks are shedding new light on a critical period in the red planet's history. All that and more still to come on SpaceTime. Scientists are working on an ambitious new dark matter experiment in space, which they hope can unravel one of the universe's greatest mysteries. For years, researchers have been baffled by the puzzling invisible force of dark matter. First identified back in the 1930s, dark matter does not emit, absorb or reflect light, making it undetectable by telescopes. Put simply, scientists have no idea what it is, but they know it exists because they can see its gravitational influence on regular so-called baryonic matter, such as preventing galaxies from flinging apart as they rotate and acting as a gravitational lens to amplify light from more distant background objects. In fact, based on these observations, we now know dark matter makes up about 85% of all the mass in the universe. That means that all the stars and galaxies, planets, gas and dust, all the trees, houses, dogs, cats, cars and people only make up 15% of the total mass budget of the universe. So trying to understand what dark matter is an important step in science's quest to understand the cosmos. Put simply, dark matter dictates the very structure of the universe, and yet it remains a complete mystery. Now, scientists have developed a new concept which could advance their understanding of dark matter. They've started testing a device that measures tiny signals by firing lasers through graphite sheets levitating in zero gravity. The study's lead author, Tim Fuchs from the University of Southampton, says it could be the first step to more space-based experiments that might one day be able to detect dark matter. He says while there are lots of theories as to what dark matter might be, no experiment on Earth so far has even come close to detecting it. But this new experiment is unlike anything attempted before. Fuchs and colleagues will levitate graphite between magnets, which in zero gravity are incredibly sensitive to small forces. If there's a sufficiently high density of dark matter, the dark wind it creates will softly push the levitated particles by a measurable amount, thereby providing the first ever direct detection of dark matter. The experimental device would be blasted into space aboard a new satellite, which is now being developed between Space South Central and the universities of Southampton, Portsmouth and Surrey under the name Jovian-1. Different options are still being explored by the Jovian-1 team, which hopes to launch the satellite early next year. The Southampton dark matter device weighs just 1.5 kilograms and, once deployed, will fly around the Earth in low orbit for about 2 years in order to conduct its tests. Fuchs says there are many theories that say dark matter's interaction rate may actually be so high that it cannot penetrate Earth's atmosphere or the mountains under which most dark matter detectors have been built. Now, this might explain why all the major experiments on Earth that have been built to try and detect dark matter haven't revealed any conclusive results.
We want to do levitated mechanics in space. The goal is to provide a proof of principle test for a new method of dark matter detection. We are not exactly sure yet ourselves what dark matter is. It's a very active field of research. So we know it has to be out there based on gravitational effects, but these are all indirect. And we don't know what makes it up because it doesn't seem to interact with light and magnetism the way our conventional matter does. It's very difficult to predict what kind of technical implementations this knowledge might yield us, but we're still in that very early fundamental inception phase.
That's physicist Tim Fuchs from the University of Southampton. And this is SpaceTime. Still to come, Martian lava rocks shedding new light on a critical phase in the red planet's history, and later in the science report, a new study warns that micro and nanoplastics are accumulating at higher rates in the human brain than in, say, the kidneys or liver. Should we be concerned? All that and more still to come on SpaceTime. A new study suggests that the Martian crust was built up by widespread volcanism rather than the volcanic hotspot remnants which dot the red planet's surface today. The findings, reported in the journal Science Advances, suggest that the igneous rocks now being examined by NASA's Mars Perseverance rover in Jezero Crater appear to date back to a crucial time period in Martian evolutionary history, a time when the internal dynamics of the planet were undergoing major changes. The study's lead author, Marieke Schmidt from Brock University, says volcanism on Mars is dominated by hotspots. These are similar to Earth's Hawaii and Iceland, where there's a focused magma source deep in the mantle which punches up through everything, including the crust, to erupt on the planet's surface. But early on in Martian history, there's modelling to support the idea that the Martian crust was built up by widespread volcanism, not necessarily focused on those hotspots, and the transition between the two is thought to have happened around the same time that these rocks now being examined by Perseverance were formed. Schmidt and colleagues used Perseverance's pixel X-ray fluorescence spectrometer to determine the fine-scale elemental composition of Martian surface materials, allowing them to remotely dive deep into the rocks to investigate how they formed and what they're made of. Schmidt says the samples from Jezero crater are thought to be at least 3.5 billion years old. Mars is very well preserved in terms of its early geological history, and so that opens a window on the early history of our solar system. See, we can't say the same for the Earth. Erosion and plate tectonics have recycled the Earth's surface, making it much harder to work out what our original planet was like. So, by studying the history of Mars, we not only better understand the inner solar system's history, but also that of the early Earth as well. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that both micro and nanoplastics accumulate at higher levels in the human brain than in the kidneys or liver. The findings reported in the journal Nature Medicine also found that levels of microplastics found in brains and livers increased between 2016 and 2024. The authors used new techniques to look for plastic particles in liver, kidney and brain samples from human bodies autopsied between 2016 and 2024, including some 52 brain specimens. In the 2016 samples, the authors detected plastics in all samples and found similar concentrations in the liver and kidneys. But brain samples from 2016 contained substantially higher concentrations of plastic particles than either the liver or the kidneys. In the 2024 samples, the authors found plastic concentrations had become much higher in brain and liver tissues than those from 2016. And interestingly, concentrations in the brain were highest in 12 people who had dementia. Now, this link between microplastics in the brain and dementia can't prove causation. So researchers want to look at a wider range of tissue samples in order to investigate the health effects of microplastics in human organs. A World Health Organization commissioned systematic review has failed to find any association between radio wave exposure and various cancers, including leukemia, lymphoma, thyroid, and oral cavity cancers. It's the second WHO-commissioned systematic review which has looked at the association between cell phones and cancer. The first, published last year, looked at the association between cell phones and brain and other head cancers and also failed to find any link. You can read the latest study in full in the journal Environment International. Scientists have bred a strain of rice which emits 70% less methane without compromising yield. Methane is a greenhouse gas, more potent than carbon dioxide, and it's become a specific concern as global warming increases. And growing rice is responsible for around 12% of global methane emissions, with demand for the staple growing. Rice emits methane due to specific chemical compounds in its roots, and researchers investigated differences between a genetically modified variety with low methane emissions and another variety with average emissions, in order to identify which compounds were determining how much methane is being released. Once they identified these compounds, the authors bred a high-yield variety of rice with a non-GMO low-emitting variety with the chemical composition they were looking for. A report in the journal Molecular Plant claims growing the plants from this crossbreeding produced 70% less methane compared with the original high-yield variety previously used for breeding. Dr. Jane Goodall, one of the planet's most respected primatologists and anthropologists, says she's certain that Sasquatch, in other words Bigfoot, is real. Sasquatch is a giant 3-metre-tall ape-like bipedal hominid purported to inhabit the North American wilderness, especially around the forests of the Pacific Northwest. It also has its counterparts, such as the Yeti or abominable snowman, which is said to roam the Himalayan mountain ranges of Asia. Although there have been thousands of alleged anecdotal sightings, lots of disputed films, video recordings, photographs, and even plaster casts of large footprints, no scientific evidence such as remains or DNA samples have ever been found. But Tim Mendham from Australian Skeptics says, for Goodall, there's no debate and no hesitancy. Bigfoot is real.
It is a fascinating story because she's a very sympathetic person. She comes across very well. She's obviously done a lot of research on chimpanzees in Africa for a long time. She's very sincere, seems to be very qualified in that area, but like a lot of scientists, you have to be very careful when they step slightly outside their areas of expertise because they're just
the Nobel Prize syndrome.
Well, yes, they're just as prone to sort of step as making a mistake as the rest of us. They're human like the rest of us. But Jane Goodall has always been a hero of everyone. It's one of those sort of people like David Attenborough, Jane Goodall, that sort of person everyone loves. But for years,
Gary,
yeah, possibly. For years, she's been making, in interviews and things, she's been saying that she definitely believes in Bigfoots and Yetis and probably Yowies, if you've ever heard of the Australian variation, Sasquatch, all that sort of stuff. She can see, she says, one is no reason not to believe it, and two, yes, it's worthwhile believing in it. So no reason not to believe it is totally pointless because it means you haven't looked at any evidence. You're trying to find evidence where something doesn't exist is very hard. You certainly have to look at those who claim that there's evidence and look at the evidence. Okay, so it's up to the claimant to put forward the evidence, really. You can't sort of say there's no evidence at all.
She's really not following the scientific method, is she?
No. Not at all. The evidence that's been put forward on the belief is poor. Very anecdotal, very sort of vague, all that sort of things, whether it's personal stories, sightings, sounds, whatever, footprints, you name it. There's always very sort of dodgy things. And because no one's actually found one, right, captured one, killed one, or whatever, it makes you only relying on this anecdotal and sort of very, very vague evidence. But that's not good enough in a scientific environment. You've got to do better than that. Thank you very much. And it seems that Jane Goodall is a scientist, qualified, very experienced in primates, etc., has been coming out over the years, and sort of not just once, it's been a whole range of different times that she said this, giving credence to Yowie, Sasquatch, Bigfoot, etc., is a worry because people will believe it because she's a believable sort of person. She's a nice person. She comes across well.
In her scientific community, that's got to affect her credibility. People have got to think she's being a nutter.
Yes, it happens a lot. But then people often allow for that and they say, yeah, well, she's a nutter in that area, but in this area she's very good. And does that override all the good things she's done? Not if you believe her. Not if you support her. Not if you have faith in her, etc. You'll just regard this as sort of an abomination, an aberration.
In this case, both. Well, we all have human foibles, I guess.
We all have human foibles. There's a story about Alfred Russel Wallace, which I've written about a number of times, who was the co-developer, discoverer of natural selection in evolution, at the same time as believing in head bumps, phrenology, believing in spiritualism, believing in all sorts of pseudosciences, etc. At the same time as being a scientist and a noted and approved scientist. The people who work with him, etc., just said, oh, that's just Alfie being a bit strange over there, but his work here is great. And you think, well, does that mean that the person himself is wrong? Is the work wrong? It's an age-old problem anyway. So Jane Goodall, because she is respected, because she comes across well, and because she gives credence to the possibility, that means it exists, and people will believe her saying it exists. And you say, Jane Goodall says, it's true, and she should know. Therefore, it must be true. Unfortunately, not.
You could say the same thing about Edwin Hubble. He believed in elves, and yet he was a brilliant astronomer. And,
yeah.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.